Hello, Precalculus student. This video is for chapter 4.5, Properties of Log Functions. So we're going to continue with using the properties of log function to work on log expressions. So in this particular examples, I'm going to use the log rules to expand a single log into multiple individual logs. So when we say individual logs, will be just log x, log y, log z, like nothing. So all these x squared and dividing and multiplying and root has to become a coefficient. So let's review the properties that we have before. So summaries of log properties are if I have the last page. If I have log and inside log m and n multiply, I can split them into add. If I have m divided by n, I can split them into subtraction. If I have an exponent, I can move the exponent out as a coefficient. So in the last example, we combine them into one. Now we are expanding one. Both of them you will need to know for getting into calculus. So this is important skill. So log no base means log base 10. So I'm just going to keep on writing that. So first of all is to split the multiply and divide. Don't worry about the exponent yet. So this are multiply, so it become add, right? So it'll be log x squared plus log cube root of y minus log z to the 4. So this is still not individual log, so I'm going to move the exponent out. 2 log x plus y to the 1/3, right? Cube root of y is y to the power 1/3. So 1/3 can move outside as log y. And then minus this 4 can move outside log z. And that's individual log, and that's how we you need to get to this point. And what about this one? I want to expand this individual log. This is a big 4th root of a over cb cubed. And there's two things in the denominator. So first of all, change this to the 1/4, right? So this would be log a over cb cubed to the 1/4. So first of all, you're going to move this 1/4. Then you might worry, okay, what about this 3 here? There's an exponent, but we'll do that later. So it's 1/4 log a over cb cubed. Now 1/4 we're going to stay outside, and you're going to split this into three things, a and c and b cubed, right? So it'll be log a minus log c, and I would want you, this is minus again log b cubed. Why? Because I am still dividing. This b cubed is in the denominator, so I do subtract. Okay. So and then I do 1/4, clean up those exponent. Log a has nothing to clean up. Log c has nothing to clean up. This 3 can move outside. Minus 3 log b. So I will be working in individual logs. So in some answer, they might want you to do the distributive properties, 1/4 log a minus 1/4 log c minus 3/4 log b. But this is also good enough. Okay. C, expand this log of y squared, y plus 3 cubed. So again, ignore the exponent. Look at the multiply and divide. So this is multiply. There's no divide. Add, you don't split, right? So it become ln y squared plus ln y plus 3 cubed. Now you're going to tackle the exponent. Move them as coefficient. 2 ln y plus 3 ln y plus 3. That's it. Right? No more. Cannot split this y and 3. Last one, you have a square root of x squared minus 1 over x. Now this square root and this square cannot cancel because you have other things inside. So I'm going to split them into the division first. So that would be equal to ln square root of x squared minus 1 minus ln x. Right? Just think of splitting as a fraction by subtraction. Now, what can I simplify this? I can simplify this as 1/2 because x squared minus 1 square root is x squared minus 1 1/2, right? That is equal to the whole thing x squared minus 1 to the power 1/2. But you can You can simplify this in. Okay, you can do that. So that would be 1/2 of ln x squared minus 1. And you can split x squared minus 1 because, and then minus ln x. Because there is not a multiplication, so you can't split them anymore. And that would be the best you can expand them, individual log. So and then the third part of 4.5 is change of base formula for log. So in our scientific calculator, we have log 10 and log base e, which is ln, right, in our scientific calculator. But if someone asks you to do log base 2 or log base 5, you don't have the button in the calculator to do it. So the change of base formula is log base bm is equal to log base m, log 10m over log 10b. Basically, the base become in the denominator, or you can do ln m over ln b. The proof of it is based on the log properties. Okay, the log properties. You can talk about this in class. Example 1, if you want to evaluate log base 5, 36, I can rewrite it as log base 10, 36 over log base 10, 5. In the calculator, it becomes log 36 over log 5. That would be 2.2266. You can use ln also. It's exactly the same. So ln 36 over ln 5. The same exactly number, 2266. Right, so this is called a change of base formula, so you can evaluate any log you want. Summaries of the log properties. So if you have log a plus b, can you split them as a plus b? No, you cannot. Can you split them as log a minus and multiply? No. If it's log a plus b inside, that is the simplest one. Log a plus b is not equal to log a plus log b, because log a plus log b can be simplified with log a times b. Log a plus b outside cannot be added inside also. If you subtract just b, you cannot move it inside or outside. But log a times b can be simplified as log a plus log b, right? And then log a times b is not log a times log b. Only this is true. Okay. Inside is multiply. You can split as add. And then if you have a times log b, you can move it as an exponent. Or if you have a number outside of the log, you can move it in as an exponent, but you cannot just move it in as a times b. And if you have log b divided by a, this means 1 over a, it becomes a root. Because you are basically it's as if you're doing 1 over a, right? 1 over a means b to the 1 over a is a root. And it is not equal to dividing inside. Okay, if you have a log b over a, is not, you cannot move the divide by a inside. It's actually a root. So this one is true. So this is true. These are not true. If you do subtract 2a, you can combine them as dividing, but you can move them as a minus b. If you have a negative log a, it is not equal to moving in, but it's actually 1 over a, because that means you can move the negative 1 as a negative 1 equal to 1 over a. Okay, a to the power negative 1 is 1 over a. Now log 0 is undefined, because anything in the log has to be greater than 0. Log negative is undefined, but log 1 is 0. So these are some of the properties of log. And we'll do 4.6, which is solving exponential and log function in the next video.